Well, this is a really dry talk title. I'm sorry about that. I'm mostly just going to talk about MCollective and the sorts of things that we've done with it, which is a slightly daunting task. Peter, who writes MCollective, is here somewhere sat at the back. Basically, that means he's going to get to answer all the technical questions that I'm not going to field at the end of this session. Thanks, Peter. So who's using MCollective, either knowingly or as part of public dashboard or any other enterprise stuff? So quite a few there. Good, this will be nice and short. It's probably good that I'm going to be short because Gareth's following me and I know how verbose he is and how many slides he's got. So if I run short, I imagine he'll expand to fill that vacuum in a figurative sense at least. So the Public Labs documentation on the website describes MCollective as a framework to build server orchestration or parallel job execution systems, which is a really exciting way to describe it. And then goes on to say it's not simply a fancy SSH for loop. Who's using a fancy SSH for loop right now? Yeah, some of you guys. Right, so you need to get on that because that's stupid. But hopefully what we're talking about here will encourage you in the right direction. So for those of you who have not seen MCollective in action, I'm not going to do a live demo because my last live demo at a previous conference went so well that I've completely used up my live demo karma for the year. I haven't sacrificed any more chicken since then, so what I'm going to do is I'm going to use diagrams. Basically, if you're using MCollective, what you will probably have is some middleware down the middle there. This is ActiveMQ, which is the kind of canonical solution to this problem. It's also a big fat Java thing, which is quite annoying when you're only using a small number of nodes with it. So there are other alternatives like Rabbit, and I believe there's an experimental Redis implementation that I'm itching to try. On the servers in your live or I guess staging and test estates, you install an MCollective server or MCollective agent, if you like, which runs constantly. It's a Ruby daemon, and that keeps a constant connection to this ActiveMQ middleware. When you're working with MCollective as a user or as a client of it, what you end up doing is you make some kind of request. And that request will make its way to the message bus, and from there it's distributed to all the agents in your data center or cluster or whatever. Depending on the criteria of the request that you've made, for example, you can limit this by fact, so you can say I only want servers that are running Red Hat rather than Ubuntu to respond to this, or you can say servers that are currently deployed with this public class, I want responses from those. The servers that self-select based on that criteria will respond with a response of some description, depending again on the request you've made, and that response is delivered to the client, which is all exciting stuff. So things you can do with MCollective, these are sort of fairly standard Puppet Labs supplied plugins. You can use ping, which is great. Exciting stuff. You can find out what servers are currently listening on in your collective, I guess is the terminology, and how quickly they respond. You can also run commands to check on the status of services. So rather than logging in with your SSH for loop and running service HTTPD status, you can do this all in one go and get responses back in parallel. And you can see on the command line here, there's a -c SF_Apache that's saying I only care about machines that have got the SF Apache class applied to them. And you can see down the bottom here just how much quicker than an SSH for loop that is. As if you needed any more reasons to get away from that lunacy. And you can also do things like check the versions of packages. So here you can see that because I'm reasonably competent, every machine in my cluster is running the same version of Apache. There's no beautiful and unique snowflakes in this particular infrastructure, which is actually a customer infrastructure. And I was thinking, well, I should probably kind of obfuscate that, but because it's EC2 and I haven't changed any of the host names, nobody knows who this is anyway. But it still looks like a fancy SSH loop. I mean, it's quicker, right? But it's on a black console with some white text, and that more or less is the type of output that you get when you're running these things over SSH. And going back to the description of what MCollective is, it's a framework to build server orchestration or parallel job execution systems. And that didn't really look like that, to be honest. But the key word here is framework. It's got hooks all over it so that you can implement your own agent behaviors, your own plugins, your own front-end behaviors. So you're not constrained with what's provided out of the box or in the contributed wiki page full of other people's plugins. You can write your own stuff and tailor it specifically to your needs. So I'm going to talk a little bit about the types of things that we've done with MCollective for our clients. We're a small consultancy. We do kind of the stuff that Tom was talking about before. We do that more or less. We also, Chris earlier on this morning mentioned that if you're a Puppet Enterprise customer, or if you're not a Puppet Enterprise customer, then they probably won't offer you professional services. We will. I was going to have a picture of a plug on the, no, never mind. So the types of things that we do is that we build more or less the same shape of infrastructure for each client. We sort of take a set of pre-built Puppet manifests around, redeploy them in various places, and so there's a lot of commonality between the customers. And some things like monitoring and software deployment are problems that need solving pretty much everywhere. So we're going to talk about monitoring first. And this should be a familiar name to anyone who's paying attention in Yoz's talk. Zabbix. I've talked about Zabbix at quite a lot of things, actually, to the point where people like Pax Publishing send me unsolicited emails and ask me to write books for free. I don't actually know Zabbix as well as that would require, but we have been using Zabbix in production for the 5 years that our company's been in existence, and sort of 3 years before that in my previous organisation. And Zabbix is a monitoring platform. It's a distributed monitoring platform. It fetches time series data. You can put triggers on that. You can compose triggers out of a number of different scenarios. So you can say, I would like there to be a trigger on my MySQL slave lag being a bit too far behind, but only when the backups aren't running, because actually that's okay during that period, etc. And it can fetch data from a number of sources, mostly the Zabbix agent, but it can also do SNMP traps and JMX. So it's a good sort of, it's a good all-rounder, really. It's the least worst solution as far as I'm concerned, and it is a solution, whereas I think things like Graphite, CollectD, StatsD, etc. that Jos was talking about previously, they're kind of components where you have to build your own solution, and we're in the market of essentially selling solutions rather than building blocks. So, it uses MySQL as its backing store, which is one of the reasons why people don't like it, because it scales as well as MySQL. And actually, MySQL doesn't scale that badly if you're holding it right, but there are still some limitations as to how quickly Zabbix can do this stuff. And the other complaint that people have with Zabbix is that configuring it looks like this. It's this big fucking web interface with loads of point and click in it. And this is just to add a new host, right? This is, I've added a machine to my network, so I'm going to go and fill in a host name, and I'm going to fill in a kind of a flashy visible name for it. I'm going to put it in some groups. I'm going to give it some IP addresses just in case you don't want to find it with name resolution, because some people hate DNS, you say.
Auto-registration, it's called.
It's what, sorry?
What you're searching for, it's auto-registration.
Auto-registration, yeah, so, okay, we'll come on to that. I have done that, and we'll talk a bit about why this solution works better for us. You can add SNMP interfaces, JMX interfaces, IPMI interfaces. It's quite big. Are you part of the Zabbix project, or are you a user of Zabbix? Okay, so we've got a Zabbix advocate here. I will curb my language. To be fair, Zabbix serves very well. It just has some annoyances. This is how you add a data point. So whereas if you're using the StatsD, Graphite, CollectD approach, you'll just put a key value pair on a network and something will take care of it. With Zabbix, you have to tell it to expect certain data points, but you configure all your sort of your expiry time and how long it will keep aggregate stats for, etc. So far, so point and click. That's quite a lot of effort for every data point you want to add. It's quite a lot of effort for every host you want to add. About as much point and click as, say, a World of Warcraft raid or something of that nature. Wouldn't it be nice if adding Zabbix hosts was as easy as this? Well, with auto-registration, which I'm going to talk about because I've been forced to, bear in mind that we wrote this about 3 years ago. So auto-registration with Zabbix, you can provide a number of ways in which it can find other hosts. So for example, it can poll lists of IP address ranges and I guess other things. Actually, the last time I did auto-registration was probably 5 years ago, and that was IP address ranges. And that was a physical infrastructure where we owned all the networking, so we knew that everything in this /27 was going to be web servers. And so we were able to add that to Zabbix. What we do now is we use this thing called MCollective that we've put together, which does essentially make life as easy as that as far as adding new hosts to Zabbix is concerned. Look out, here comes some Ruby, sort of. This is the kind of the basis of what we do within MCollective for finding servers to monitor. What we're doing here is we're using MCollective and saying, discover all the nodes. Tell me what is on the network right now, which is broadly equivalent to the mco ping command that I showed you a screenshot of earlier on. And for every host in that set of responses, we're going to walk through them and we're going to ask it for its inventory, and the inventory will return, amongst other things, a bunch of facts about that node. And from those facts, we can establish certain things about the machine, such as its IP address, its hostname. Things like we use specific facts to designate roles to machines. So we have a sort of nodeless setup where we use 3 types of facts on the machine to have it determine what sort of machine it's going to be. And we fetch all those as well. And then we do some Zabbix magic, and then that's that. The Zabbix magic is pseudocode because that's actually a lot bigger. Zabbix provides an API for doing these sorts of things. And so for every host that we find, if the host isn't already in Zabbix, then we add it using the API. Then we enumerate all of the public classes that are applied to that host that we've discovered from the inventory call. And we add, for each of those that matches a Zabbix template name. So for example, SF Apache covers our Apache install. We also have an SF Apache template in Zabbix, which then contains the things that we think we want to monitor about Apache. So for example, is it up? Is it listening on the port it's supposed to be listening to? And some numerical data that comes via mod status. So we assign those templates to the host. If the host is already in Zabbix, then we again enumerate the templates and make sure that we've got all of them there. So if the node changes over time, then the Zabbix configuration changes as well. And the bit that's missing there actually is if the host, if it finds a host in Zabbix that doesn't exist anymore, then it warns but stays quiet about it. And part of the reason for that is that in the Amazon EC2 world, you don't necessarily have all your servers there all the time. Some of them might be elastic, some of them come and go with different host names, and this is a fairly straightforward way of doing the type of auto discovery we might want to do with Zabbix, but in a completely dynamic elastic environment with some integration with Puppet, so that we can say, this thing that Puppet has asked the machine to do, let's check that it is actually doing that thing. And that for us is the kind of closing the monitoring loop. You're saying, Puppet says do this thing, monitoring saying, is the machine doing this thing? If everything's green, you can be reasonably sure that everything's working properly, as long as you've instrumented everything correctly and figured it right, but that's the problem for other people. So back to the diagram, because this is exciting. If we add a new node to the network, the MCollective job runs on cron on the Zabbix server periodically, every 15 minutes or something of that nature. It puts a message onto the middleware. The middleware passes that to the server. The server goes, oh, I'm a server, I can reply to that. Sends a response, and that gets back to the MCollective client. MCollective makes an API call against Zabbix, and then Zabbix knows that it can then monitor those machines. It's relatively straightforward. The code is on GitHub. Feel free to pick it apart. Do tell me if there's a way of doing this with pure Zabbix that I've missed, or that is new since I wrote this. It's all available to tinker with. So that's not the only thing that we've built on top of the MCollective framework. We also have some tooling around software deployment, and I'm going to describe briefly the traditional deployment approach. It's very easy. You send software to all the servers you know about. Done. Everyone using Capistrano, Fabric, anything of that nature. This is your sort of traditional approach. You've got a Jenkins machine. Your Git code changes. Somebody presses a button, or maybe you're in that magical world of continuous delivery where you just throw it out and hopefully it works. That's what it is, right? I have read the Humble and Farley book, but I was fuzzy on the details. And this is relatively straightforward. But again, in a sort of cloud environment or an elastic environment, you don't necessarily know where all those machines are. And you could do something like query the AWS API, or you could query the Cloud Stack API or whatever. We have an agnostic solution that will solve this to some extent, that we call SF Deploy. And I'm going to take absolutely no credit for the, I guess, the design of this, because it's something that we wrote soon after. I think it was either a previous Puppet camp or it was at DevOps Days, where Sam, who was at IPC Media, I want to say, one of the publishing companies, talked about how they were doing software deployment in this kind of way. And the primary difference is, in a traditional software deployment, you are pushing code from somewhere to your production estate. And what we do with SF Deploy, and what Sam's software was doing at IPC, but that wasn't open source, which is why we did this, is pull-based deploy. So what we're actually doing here is using MCollective to trigger activities on a machine that will lead to a new deployment of software. So, as a way to describe this, again, I'm going to use some diagrams. Hopefully this will be relatively easy to follow. So, let's say you've committed your change to Git, and maybe you've got a Jenkins job that is keeping an eye on your Git repository, or a webhook or whatever, that's picking this stuff up. And that job triggers automatically, and it sends out a call onto the message bus via MCollective. And what you're doing is saying, hello live servers, what I would like you to do is to update a Git repository on yourself that matches the configuration of the application that we're talking about. So each of these machines has a bare Git clone of the same source repository that your Jenkins job is watching. And on firing this command over MCollective, your nodes wake up and they will Git pull inside that bare repository. So now that Git, the bare Git clones that are on these servers are now as up to date with the things that you're writing as your central repository in GitHub or Bitbucket or wherever you're storing these things. And so the latest code you see on the stage left, right hand side there, goes up one value because now you've got the latest code on there. And you can keep doing this. So if you're doing this across a network of hundreds of machines, every time you commit some code, they're going to kick it up and pull down some new code. That's obviously a scale problem. We haven't needed to solve that one, but it wouldn't be difficult necessarily. From there, when you're ready to push out new code, you can do so by, again, using MCollective and saying, for the application, my website, I would like all of the machines that are in this cluster or this region or however you're doing your blue-green deployment, if that's what you want to do. Please update to either this SHA-SUM, this tag, this the latest head of the the tip of the master branch. Doesn't matter what, but you can have your Jenkins job ask for that. And at that point, your Jenkins job is again going to talk to the message queue. MCollective is going to spread that to all of the machines, and your deploy happens. And the legwork of the deploy is done by basically creating a new number directory, Git cloning from the bare clone into there, symlinking some shared files. Actually, it sounds quite a lot like Capistrano. It kind of is. But we were trying to handle more or less the same use case that we use for Capistrano, but in a more pull-based method. We have currently one customer using this approach, another one coming online soon, and it generally works for us. It means that your deployments are as quick as it takes for code to come out of a Git repository into a clone, and those of you who are using Git know that that is pretty quick. Those of you who are not using Git, why not? And the code for SF Deploy, this is an application end bit of Ruby. So this runs on the client, the bit that Jenkins kicks off, and you see that it's as straightforward as deriving from a superclass, overriding a main method, and using an RPC client to say, do this thing, and all the configuration items there are just command line flags that get passed straight into it. And those command line flags get passed over the message bus as part of the request to the agent, which is the thing that runs as a plugin inside the servers running on your production infrastructure. That's going to accept the request that you've sent over from the client, and then pass the same arguments essentially to a command line binary, which does all the hard work, either as another user or not, depending on how you do it. It's really straightforward, it's optimized and simple. There's no management of SSH keys or anything, that's just done in the user's account that you're using to deploy. Dead easy. Again, on GitHub, if you want to check that out, contribute to it, see if you can break it, all those sorts of things. That's basically a flavour of it. I guess my main point here really is that the MCollective as a framework is actually really easy to do stuff against. It's quite straightforward to build plugins and applications. If you're using the DDL to describe how the output is formatted, in theory it plugs straight into the dashboard. I don't know whether that's actually true because I don't pay Puppet Labs any money, sorry. And if you are interested in doing that, then there's an absolute truckload of documentation on the Puppet Labs website about how to do that exactly. In all fairness, I couldn't right now sit down and bash out a new MCollective agent plugin. I followed this, looked in some of the contributed sources, and just sort of picked it up as I went along, which is why Peter will answer any of the technical questions. There's a question there. Oh, sorry.
Yeah, so did you see that original pattern at DevOps days?
Yes, yeah.
From Future Publishing?
Future Publishing, that's right, yeah.
John wrote the original.
Okay, so how does it compare?
Quite close.
Okay. It isn't open source, is it? I could never find it. It is open source now.
It is now.
Okay, how long has it been open source?
Since about the day after the...
My wheels fly around.
No, you're right.
Cool, well maybe we'll compare notes.
Yeah, sure.
Yeah, but that's pretty much it. I don't really have anything much to add. You should take it away and give it a go. I think the things that are tricky I find about implementing stuff with MCollective is debugging anything that runs in parallel is always hard work. It's a kind of distributed systems problem. MCollective can be quite verbose about what it wants if you're trying to troubleshoot stuff. But other than that, it is a fine platform for doing this sort of thing with. Any more questions? Yes.
How do you make it reliable?
How do you make it reliable? That's Peter's problem. So the deployment works idempotently. Like if you say deploy this SHA sum, it'll keep deploying the same SHA sum over and over again in a different number and location. It's not something we've given a huge amount of thought to. There are methods in SF deploy which will report on the versions that are deployed currently. So you could build a tool to say, is everything at the version that I expected it to be? But yeah, it's not a problem that we've needed to solve because it just tends to work.
I was just curious, going back to the fancy 4SSH loop thing.
Yes.
Where'd you get the parallelism from? Is that just in the code?
So MCollective works in parallel by default, or at least it's so because you're putting it works on a publish subscribe model. So all of the agents are subscribed to a topic that relates to the collective. And when you ask a question, that fans out to all of those agents simultaneously just by virtue of how the middleware works. The responses come back, I guess they're iterated through. I haven't actually looked at the stomp details, but the machines themselves will do that work simultaneously because they've had the request more or less at the same time because it's fanned out in the bus.
And on a site with thousands of nodes, can you configure the parallelism? So it's like in groups or
Yeah, so one of the plugins you can use with MCollective is one to trigger a Puppet run. So if you've got the Puppet agent running on your nodes, you can say, run the agent now. That command takes a flag that says do this in batches of however many. I don't know if that's a feature that is just something that MCollective can do, or whether it's something that I would have to build into the deploy tool in order to make it do that. I'm looking at Peter. Yes, yeah, definitely one of those. But yeah, it's doable.
Okay.
Yeah.
Do you do any validation beforehand of how many nodes you need to update and how many nodes you updated? Do you run cases where you have like some node not upgraded because of the ASIC being down or something like that?
So the question was, do we do any validation of which machines need upgrading or updating? Not currently. It's a very straightforward tool at the moment. The customers that are using this they're deploying to sort of 8 machines at once. It's not a huge ask. Everything that we do really is kind of optimized for reuse. So although in that particular customer they're doing it on EC2 and for a small number of nodes, the next customer we do it for might be much bigger or on a different platform. And if there is a need to do that level of validation, we'll put that in. But it's not a massively robust implementation right now. But it is at least as good as Capistrano. But that might not be true now that Capistrano 3 is out, but I haven't looked today. Anyone else? Nope. Cool, thank you very much.